This is part 2, solving for an unknown with algebra. Sometimes you have to convert units when solving for a variable. And here's an example. It involves the change in temperature needed to change the length of a 10-meter rail by 2 millimeters. So here's the equation. That's the change in length, 2 millimeters. That's the original length, 10 meters. This is the thermal expansion coefficient. And there's the change in temperature. We want to solve for the change in temperature. What's delta T? So to isolate delta T, we're going to divide by everything that's multiplied by the delta T. This whole thing here. Then we get delta T by itself. All of this cancels, and we have delta T. That's what it looks like now, and we have a little bit of a problem because we have millimeters in the numerator and meters in the denominator. Those units don't cancel. We're going to have to convert one of them. So let's convert the unit of the length of 2 millimeters to meters. There are 1,000 millimeters in a meter, so we multiply by 1. 2 millimeters times 1 is 0.002 meters. That's the same length. So now we can substitute that in for 2 millimeters. And the meters units cancel. And we're making progress. That's the goal. So we now have this. And there's a little bit of a problem. We have the Fahrenheit unit is in the denominator of a fraction that's in the denominator. So we have to deal with that. And there's a number of ways to do it. All of them work if you do it right. So we're going to multiply the left-hand side by 1, which is degrees Fahrenheit over degrees Fahrenheit. Multiply something by 1, its value doesn't change. So in the denominator, we have Fahrenheit in the top and Fahrenheit in the bottom. So these two Fahrenheits cancel. And this leaves 1 in the numerator. So those two cancel. And now we have 1 here. And we can rewrite this like that, and we have a bunch of numbers, and we have the unit. So we get a calculator, and we calculate the number. And it turned out to be 100. So the change in temperature needed to increase the length of a 10-meter steel rail by 2 millimeters is 100 degrees Fahrenheit. So if you're thinking it's a lot easier to do this without the units, yeah, you're right, but you need the units. Giving a number is not useful. And it's embarrassing if you give a number without a unit. That's part 2.